From an airplane window, you've probably seen them. Enormous green circles stamped across a brown landscape, far too perfect to be natural. Those circles are farms. Each one is drawn by a single machine called a center pivot. It's a long pipe, sometimes a quarter of a mile of it, mounted on wheeled towers that slowly walk in a circle around a central point. As it rotates, sprinklers along its length rain water onto the crop, tracing out a perfect green disc. From the ground, it just looks like an ordinary field. From the sky, it looks like modern art. And it may be the single most important reason we can grow food in places that really should be desert. To understand why it matters, picture the American high plains. Nebraska, Kansas, the Texas Panhandle. Flat, endlessly sunny, with deep and genuinely rich soil, but far too dry to farm reliably. In the 1930s, this was the heart of the Dust Bowl, where years of drought turned the loose topsoil into choking black clouds and drove hundreds of thousands of families off their land. The sunlight was there. The soil was there. The one missing ingredient was water, delivered evenly and delivered on demand. The fix came from a Nebraska farmer named Frank Zybach. In 1948, tinkering in his own workshop, he built a self-propelled sprinkler that could water an entire field by itself, and he patented it in 1952. A manufacturer named Robert Doherty saw the strange machine, immediately bought the rights, and started building them at scale. What began as one farmer's homemade contraption quietly became an industry that would redraw the map of American agriculture. The design is beautifully simple. At the center sits a well pumping groundwater up into the pipe. The pipe stretches out across the field on a row of A-shaped towers, each one riding on its own set of wheels. The earliest machines were pushed around by the water pressure itself. Today, small electric motors at each tower creep them forward, all carefully synchronized, so the whole arm sweeps around the center like the hand of a giant clock. Water sprays down the entire length as it turns. One machine, one operator, watering a whole field on its own day and night. But a pivot can only reach as far as its pipe is long, and it can only swing in a circle. So on a square field, the four corners are always left dry. That is exactly why the landscape is dotted with green circles sitting inside brown squares. A standard quarter-mile pivot on a 160-acre square waters only about 130 of those acres, leaving the corners for a dryland crop or for nothing at all. The circle isn't a design choice anyone made. It's simply the honest shape of a rotating arm. Modern pivots do far more than just sprinkle water. Because every single drop passes through that central pipe, farmers can dissolve fertilizer and even crop protection directly into the flow, feeding the plants and watering them in one pass. The industry calls it fertigation. The newest machines carry GPS and variable rate nozzles, so a single pivot can water a sandy rise more heavily than a damp hollow, adjusting itself foot by foot as it turns. Older systems flung water high into the air, where much of it evaporated before it ever hit the ground. Today's low-pressure drop nozzles hang the water just above the crop, cutting that waste dramatically. A center pivot is no longer a dumb sprinkler on wheels. It's a rolling, computer-guided delivery system that places water and nutrients almost exactly where each part of the field needs them. And the transformation this enabled is genuinely staggering. In Kansas, in 1950, irrigated cropland covered only about 250,000 acres. After center pivots arrived, that number climbed to nearly 3 million. Across the whole country, by 2013, center pivots were watering close to 28 million acres on 57,000 farms, making it the most widely used irrigation method in America. Land that had once literally blown away in the wind became one of the most productive breadbaskets on Earth, growing the corn and wheat that feed people and livestock all over the world. And these circles are no longer just an American story. Fly over the deserts of Saudi Arabia, and you will find thousands of brilliant green pivot circles blooming in what is otherwise pure sand, fed by ancient water pumped from far below. They appear across Egypt, Libya, Australia, and the dry plains of South America. In fact, the pattern is so bold and so geometric that center pivot fields are one of the clearest human fingerprints visible from space. Astronauts on the space station routinely photograph them, tidy clusters of green coins scattered across otherwise empty land. Wherever there is strong sun, flat ground, and water somewhere beneath the surface, the center pivot has followed, turning blank map into cropland. There's just one problem, and it runs deep underground. Most of that water comes from the Ogallala aquifer, a vast layer of water-soaked rock sitting beneath 8 states. But this is not a river that refills every year. Much of it is fossil water, left over from the last ice age, that trickles back at a glacial pace. 60 years of relentless pumping for all those green circles has drained parts of the aquifer far faster than nature can ever replace it. In some areas, wells that once gushed now run dry. Refilling what has already been pumped out would take hundreds, even thousands of years of steady rain. So the next time you fly over the plains and see those flawless green circles, look a little closer. Each one is a small miracle of engineering, a machine that turned a dust bowl back into farmland. But each one is also drinking from a well that took 100 centuries to fill and only a few decades to drain. They are, all at once, one of humanity's cleverest inventions and a quiet countdown clock written across the land. Follow along for more of the hidden systems that quietly decide what ends up on your plate.